welcome to BSS Studies. I am Bala. Today I will explain about graphs. So we already learned about introduction of graphs. What is introduction? Here this is y coordinate, y axis. This is y axis and this is x axis. This is y axis and this is x axis and this is z axis. Okay, so for representing graphs we have to know about the Cartesian coordinate system. Cartesian coordinate system, which means this only: y axis, x axis, z axis. Here the z axis represents like this. Here like this will z axis represents, and this is y axis and this is x axis. So there is no need of z axis in these graphs. Okay. So this point in this point is origin. This point is origin, which means 0. This point starts from 0, 0, 1. If I take this 0, 1, 2, 3, 4, 4 and so on, 4, 5. So this is 1, 2, 3, 4, 5 and so on. Okay. So like this we can represent the numbers also in graphs. Okay. So this is a normal graph with y-axis and x-axis. Okay. So if I take this point, here I am taking the values 1, 2, 3 and here 1, 2 and 3, 4. If I take like this numbers in this coordinate system, this is one of the point in this plane. Here this plane is xy plane. Okay. So if I take this point in this xy plane, here this point, the measure of this point with respect to x-axis and y-axis is, I will repeat again, the measure of this point with respect to x-axis and y-axis is, see here, this is straight to 2 and this is also for 3. Okay. So this point, the measure is, first we have to write with number 2. We have to start the number of x-axis. So 2, 3. Here this is 3. So this is y-axis number. So this is 2, 3. This is a ordered pair which we represent in this like this small brackets, and we have to write the numbers of this xy plane. Okay. So this is an ordered pair. Remember this? This is an ordered pair. Okay. So this is the basic introduction of this coordinate system or graphs. Okay. So who is invented graphs? René Descartes. He is a mathematician who invented this coordinate system. Okay. So he is an inventor for this coordinate system. So this is our basic introduction. So if we see, and this is graph. So if we see, we already learnt about the slope. Slope. What is slope? y2 minus y1 by x2 minus x1. Okay. y2 minus y1 by x2 minus x1. So this slope is also found as theta. If I take, this is a straight line between these two axes. So if I give 45 degrees, so this 45, if you substitute that 45 degrees in this, we get 1. Okay, so the 1 of this tan 45 means 1. This 1 represents the slope of this line. Okay, so this 1 represents the slope of this line. Or we can find with the formula slope y2 minus y1 by x2 minus x1. Okay, here y2 minus y1 means, here this is, I am taking y-axis like this, and this is x-axis. So if I take like this 2 points, P1 and this is P2. Okay, so here this is y1 because P1 point first we had to represent. So this is y1 and this is y2. I will draw somewhere. So this is P2, which is nothing but y2, and this is x1. Okay, and this is x2. Okay, so like this we can say that this is x1 and this is x2 and this is y1 and this is y2. Okay, so this is x1, x2, y1, y2. If we substitute these values in this given formula, for example, these are the numbers. So if we substitute, x1 means 2, x2 means 3, y1 means 2, y2 means 3. So if we substitute these values in this formula, we get same answer. Slope is 1 only. Here I gave that this is a 45 degrees. Okay. So this is what we had discussed in yesterday. So if you see in graphs, and in graphs we already learned if a straight line will be there like this, if a straight line is there like this, the slope is constant. Slope is constant. Okay, if straight line is there, but in curvy line like this, if there is a curvy line like this, the slope varies from point to point. The slope varies from point to point. The slope varies from this point to this point, or this point to this point, or this point to this point, or this point to this point. In a curvy line, in a straight line, slope is constant. In a curvy line, slope is not constant. Slope is not constant. Okay. So slope is constant in a straight line and slope is not constant in a curvy line. Okay. So if you see here, ST graphs. ST graphs. ST graphs is nothing but distance time graphs. distance, time graphs. So in this first one, uniform motion. Uniform motion. Uniform motion means if I take like this, in this a straight line is there. It represents, I am taking this is S distance and this is T. If I take like this a straight line, this represents the uniform motion. Uniform motion means there is no change in distance or time. Equal distance in equal interval of time. So uniform motion means equal distance in equal interval of time. So we can say this is a uniform motion graph. Okay. Here this, in this, if I take slope, if I find slope of above graph represents velocity. Slope of above graph represents velocity. So here I am taking this is a point and this is a point. If I find this slope represents velocity. Okay. So this is first graph, uniform motion. Second one, non-uniform motion. Non-uniform motion. So non-uniform motion means unequal distances in unequal interval of time or unequal distances in equal interval of time, anything. So I am taking, this is a non-uniform motion graph. Okay, so like this we can find the slope from this or from this, or here there is a curvy lines. So curvy lines means automatically slope is not constant. Slope is not constant. Okay, so this graph represents non-uniform motion. Okay, so this is second graph. And third graph, rest. Rest means like this, S, T. If I start from this, rest means like this. Okay, like this, plane. This is rest. So here if we find slope, we can say that the slope of this point to this point is 0. If 0 is the slope of this point to this point, this graph represents rest motion. Okay. If slope is constant and if constant is 0, so we can say this graph is in rest motion. Okay, this graph is in rest motion. Okay, so these are the three distance and time graphs. And today topic is completed. ఈ వీడియో కనుక మీకు నచ్చినట్లయితే ప్లీజ్ లైక్ చేయండి, షేర్ చేయండి, సబ్స్క్రైబ్ చేయండి. If you have any doubts, please comment on the comment box. Thank you.